So now the percent error is going to be 7.59 minus the approximate, which was 7.6. Wow, you see how far over we went, right? Went over by what, 100th? But it was an overestimate, right? Concave down scenario, overestimate, not by much. Divided by the 7.59 times 100. There's our percent error. Actual error is 100th. We understand? Let's do one which.
And then where did you get the 7.6 from?
That was our approximation.
Okay.
7.6 was the approximation.
Okay.
Number 9. The function is ln of 1 plus x. Same as the questions. So here's where it's more reasonable to get an approximate because you don't know how to compute things inside a natural log. And the a value is 0. 0. And eventually we're going to try to approximate f of 1.9. 1 point, no, I lied, 0.9. All right. So same thing. First thing is find the linear approximator. So A. Find L of x. Perhaps this time we'll take as much care as last time. So f of A. First we need to find f of what? 0? What's f of 0? ln of 1, which is 0, right? F prime of x. 1 over 1 plus x times the derivative of 1 plus x, which is 1. So 1 over 1 plus x. Agreed? Derivative is natural log. So 1 over 1 plus x. F prime at 0 is 1. X minus a is x minus 0. So just x. All right, so we're just plugging the pieces now. Lx is going to be the original height we're starting at, plus an extra height which helps to approximate. So what? 1 times x. Is that right? You're right. Because x minus 0, right? So just where is x? Is that okay? This is right?
So is it just x?
Yeah. Linear approximation in this case is the identity function x. Right. But that is the same as our tangent line to this curve at 0. That's what we found. What was part 2? Draw the graph.
So right now, that was pretty much step 1, just find L of x.
That's right. That was all step 1. That was part A. Part B. Graph. F and L. Who can tell me what happened to the natural log of x when I put in ln of 1 plus x? What happens to it? The original natural log function, which I know what it looks like, what happens if you put in 1 plus x in place of x? Moves to the left 1 place. Is that right? Moves to the left 1 place. So that means its asymptote, which was at x equals 0 is now x equals -1. So now we have this picture, and its y-intercept, sorry, its x-intercept, which was at 1, is now moved back to the origin. So it should go through the origin, and then look like natural log, any other natural log. So that is f of x equals ln 1 plus x. That's why we're allowed to put in 0 to this thing, right? Normally natural log can't take in 0, because we move the whole thing back one step. So now you can put in 0 and get out 0, like we just showed, right? We put in 0, we got natural log of 1, which is 0, showing that it goes to the origin. But this is the point of concern, and we have found the tangent line there. Its slope was what? 1? Exactly like my picture. A perfect 1 slope there. That is the function x. That blue line, certainly. That is L of x equals the identity function x, right? Lee, you think it looks like x?
Yes.
Thank you. All right. Man. Give you bonus points.
Whoa.
You should have piped up faster. Yes, right. You should have commented on how beautiful this graph looks more quickly.
You didn't ask me.
All right.
You always go to him. Compliments.
Did you have Poetry Pro today? Is that what happened?
That what? Poetry Pro?
Yeah.
No, still not. No. Even though it tempts me every time we drive by. I just want to drive in there and get some good old Poyo, but no. All right.
I heard they're going kosher.
It's a lie. For all those Jewish Mexicans out there, right?
Yeah.
Exactly. Exactly. All right. So anyway, that was part B. We drew the picture. Now I want to approximate this thing at 0.9. That was part B. Now part C. Where's the green? I lost the green. There it is. Compartmentalize this thing here. Part C. Find an approximate of f at 0.9. So what we're doing here is we're going over to 0.9, which I guess is, if I drew this better, there's 0.9, yeah? Okay, for 0.9 if this is scale 1. So instead of mapping up to the curve, because we don't know where that's at, right? Now what's natural log of, what are we really finding here? F of 0.9. What is this function at 0.9? I don't know. Anybody know what natural log of 1.9 is?
0.64.
No, I said, is any one? Is any human? Does any human know what ln of 1.9 is? Any humans out there that know ln of 1.9?
I do.
Do not.
Yeah,
What? Any humans? Yeah, you know what they did? You know what the calculator does? This. This is exactly what your calculator does.
What's it do?
This. The process we're going through right now. When you punch your numbers in your calculator, when you punch ln of 1.9 in your calculator, you know what it does? This. Now, it may do a little bit fancier. It may not give you a linear approximation, it may give you a quadratic, may put an extra term on here or something. But this whole process we're doing is the baby steps of something you do in Calc 2, and you can take a larger approximating polynomials. That's all your computer's doing. Right?
0.64.
What do you get? 0.641?
That's what I got.
Meaning when you punched ln 1.9 in.
No, I
Yeah.
did that in my
I
head.
just took